Hello, welcome to Hybrid Clouds demo. This demo extends the microservices with KubeMQ demo by adding the ability to bridge the on-prem Kubernetes cluster to a remote cloud-based cluster and provide the services on the local cluster to the application that's running on the remote cluster. In this demo, we will add to our setup the KubeMQ Bridges connector. The Bridges connector allows connecting KubeMQ cluster in a bridging, aggregating, and replication topologies no matter where they are located. In our setup, we will deploy KubeMQ bridges locally and bridge the Redis, Postgres, and Elastic query channels to the cluster that's running remotely on the GKE Kubernetes cluster. We will use the same application that we use in the microservices demo, but this time we will connect the KubeMQ cluster on the GKE and consume the Redis, Postgres, and Elastic services that runs on the local on-prem Kubernetes cluster. Let's get started. Before we start our demo, let's first check that our local installation of microservices, as we did in the other demo of the microservices with KubeMQ, let's first check that it works and all the configuration and all the integration are intact. So in order to do this, we will use the KubeMQ CTL M for manager, and let's see the integration that's already running. And as we can see, we have three integration that already we defined. The first one is the Redis, going to a channel of query Redis, Postgres, and Elastic. Both of them are going to their respective channels, Postgres and Elastic. The best way to see it, and we will do it again, we'll go to the local one and we'll run the application and see that everything works. We see the request for Redis, and we see the request for Postgres, and we see the request for Elastic. Back to our configuration, we will see first that we have another cluster, KubeMQ cluster, that is already configured on GKE. In this case, we use a Google Cloud infrastructure. We can do this by changing the Kubernetes context, and we can see that I have here GKE. We can go to clusters, git list cluster, and you can see that I have one with 3 replicas. Another thing that we'd like to check is the interface that expose outside in order for us to connect our connectors from one hand. On the second hand, we'd like to connect our remote application directly. So when I already configured this KubeMQ cluster, I exposed the gRPC interface. We can see it with kubectl, get svc, and KubeMQ namespace. And we can see that we have the gRPC interface exposed on load balancer with external IP 34.71.46.230. This is important because we need this interface and this IP in order to connect our connectors and also our application going forward. After we saw that all our prerequisites are up and running, let's start and configure the bridge connector. The bridge connector is a connector that from one end connect to a remote KubeMQ cluster, and the second end is connected to a local one. Now, since we checked before with the context of the GKE, we will now again start with KubeMQ, CTL, M, and I will switch back to my local one. So we will start by adding a connector. It will be a binding. We're going to be a bridge. We're going to call it a KubeMQ bridges. It will sit on the KubeMQ namespace. And now I'm going to add a binding. A binding is a connection between a source and a target. We will do 3 bindings for each of the services. We're going to do a Redis binding, a Postgres binding, and Elastic binding. And we're going to bridge the same queries that coming from the remote cluster to the query that is on the local cluster. So we're going to start by adding a binding called Redis. Now I'm going to pick the query, and here I'm going to put the load balancer of the GKE cluster that I have in the context of the gRPC connection. Here I'm going to put here this one. The channel will be Redis. And I'm going to select the target again, query. And here I'm going to put the local one interface and the same Redis. And I have now a new binding, list of binding. We can see that I have Redis. We will do the same for Postgres and Elastic. We could do it. Postgres, query, the same connection to GKE, Postgres, channel. Are we going to forward again to the local one? Postgres. And now I'm going to add the Elastic one. And target. So now we can see that we have three bindings. Redis, Postgres, and Elastic. We can see each one of them. Their configuration, correct. We will save this, save our connector, and let the connector up and running. We can see the list of connector. We can see that we have three connectors. One is the bridges that we configure currently now, and the sources and targets. This is what we did in our previous demo of the microservices. Now, after we configured our remote and bridging, we can test it with the same application that we have in the local one. We can see it here. Again, we can run it to see that everything is run. And I have the same application that running, but instead connecting to the local cluster, is going to connect to the remote cluster in GKE, and we can run it. And here we can see that it's do the same, a little bit more slower because now we are connecting to the remote one. And you can see that we have the connection string is 34.71.46.230, and port 50,000 is the remote one. So if we can recap, we have built a network of microservices that can be accessed from two locations. The first location is a local one, is any kind of application or service that can run on a container locally in the Kubernetes cluster. This is what we saw here. And we connect a remote cluster, in our case a GKE cluster, to our local resources of Redis, Elastic, and Postgres with bridges, and allow services that running remotely to get a service from Redis, Postgres, and Elastic. We can see it here again. We can see that we have all the connectors. We can see the configuration of our bridges. If we can see, we have three bindings, Elastic, Postgres, and Redis. All of them, they have a source that's listening to KubeMQ in port 50,000 in the local balancer, and forward the information inside. This concludes our demo. If you would like to try KubeMQ, please visit us at kubemq.io/quickstart. Thank you for watching. See you at the next demo.